our class from this slide. I think we talked about this slide in the last class, isn't it?
Yes, sir.
Okay, very good. So we have given an assignment also. So see the Google Classroom and submit it very quickly because you don't have much time left. And these class tests are actually similar to the class quiz. So submit the assignment, and I will decide whether I will give it as a class test or not. Okay. So this theorem of 2.15 already we have
Sorry,
seen.
sir,
Yes,
sorry. The class test, is it going to be MCQ or is going to be theory? We
it
will write and
is.
then
It is
start.
going to be. It is going to be MCQ. It is going to be MCQ. But the thing is, actually, it is a descriptive. I mean, mathematical class test. But there will be MCQ answer for that class test, and you will solve it by yourself, and then find out the result, and then give the answer. Actually, MCQ means it's not like A, B, C, D. It
Oh,
will be
okay.
there will be 10 options.
An
10
option.
options. There will be for every question there will be 10 answer, and
Oh God.
and and you have to choose. You have to choose the answer from that. Okay, so
But only one answer is correct, right?
only one answer is correct, right? Definitely, definitely.
So 10 is not too much. You will get confused.
Yeah. So it is very difficult to guess, because the MCQ has a problem. Sometimes we don't know the answer, but we guess,
Yes.
and we sometimes guess it right. So
So
if
5 is okay.
yes, yes. So the thing is, if there are 10 answers, then it will be difficult to guess, definitely. So you have to solve the problem and find the exact result, and then only you can put the answer. Okay. And remember one thing, that I mean, do not try to see others paper and just put the answer, and then actually because there will be different kind of questions in different kind of order, for everyone. so
Okay.
so it will be difficult. So yeah, I will give very small time, because uh, uh, I will give only 10 minutes for a 15-mark question,
10 minutes and we have to solve, right?
and you have to
Too
solve,
difficult.
because there is no think about no thing about taking a snapshot and submit. So there is no problem like that. You just solve it in your paper, and then uh, MCQ. So just click.
So I got 10 minutes is too small.
10 minutes is too small, I understand, but the
We
thing
have
is,
to solve.
if I give you more time, then people will try to see others cheat like these things. This is
Maybe
a
you
problem.
adjust it to 15. I think it's better.
The thing is, there will be relative grading. So if the highest mark is 10, then he will get 15 out of 15. You understand? So the thing is, uh, there will be relative grading. So if someone can answer all the questions in 10 minutes, then actually the highest mark will be 15. So I hope that it will be good. So try to do it by yourself, because if you try to see someone, then your time will be wasted, and you
Yes.
will lose time in calculating. Okay. So let's see how it works. So try to find the date. All right. So the thing is, let's go to the next slide, and this is the um, this is one kind of quiz. One kind of quiz. I mean, quiz means actually it's a problem. It's a problem, and this problem, how can we solve it? Let's see. Look at this one. We have been given a PMF. We have been given a PMF here, and we need to solve. We need to find out the expected value, the second moment, the variance, then the standard deviation. You can understand, if we can find out the variance, standard deviation is very easy. isn't it? Because we know that the standard deviation will be equals to root over variance, isn't it? All right. So the thing is, if somehow we can find out the variance, we can easily find out the standard deviation. Now, how can we find the variance? Remember one thing, if I can remember, variance of n is equal to expected value of n square minus expected value of n whole square. So if somehow we can find the value of en square and en, then we can find the value of variance of n. So look at that. If question number 1 can be found and also question number 2 can be answered, then from these two we can find the variance, isn't it? And from
Yes.
this variance we can find the last one, that is the standard deviation. So there is only two part actually in this question, this en and this en square. So if somehow we can find the en, then we can find and also we can find the en square, then we can find variance, we can find standard deviation. Now how can we find expected value of n? We know very well that this is n pn summation. Can we remember? If you can,
Yes, sir.
if you can remember, then actually we can think about it, isn't it? Thing is, for finding this expected value of n, we can use this formula, and we have the value like this. So what is the value of n? N actually this one, 0, 1, 2. So when n equal to 0, Pn equals to 0.1 plus when n equal to 1, Pn equals to 0.4, then plus when n equals to 2, then Pn equals to 0.5, and then 0 otherwise means we don't need to add because that will be multiplied by 0 and you'll not find any value. Okay, so the thing is, we're having 3 values for 3 different value and we have added them. So what is the result? 0.1 plus 0.4 plus 1. So that will be 1.
This 0.1
0.1 should be
it
0.
will be 0. 0.1 into 0.
Why 0?
Sir,
Oh, 0.1 into 0. Right. Right. You are right. So that will be 0. Very good. And that will be 0.4 and that will be 1. Okay. So 1.4. So 1.4 we have found out. So this En will be equals to 1.4. All right. Then what is En square? Remember one thing. Like En square will also be something like n square
Squared PNN.
Pn summation. Isn't it? And that
Yes,
will
sir.
be what n square means, 0 square into Pn plus 1 square into Pn plus 2 square into Pn. Okay, that will be 0. That will be what? Again 0.4. That will be into 2. I mean that is plus 2. That means 2.4. So this will be equals to 1.4. That will be equals to 2.4. So these two values we have already found out after calculation. Is it clear?
yes, sir.
Okay. So the thing is that if I omit, then how to find out this variance of n?
Sir, by
Very easy.
subtracting
Very easy. 2.4 minus 1.4 equals to 1. What is the standard deviation? Root over 1 equals to 1. Isn't it?
Yes,
So it's
sir.
very easy.
Yes, sir.
Very easy. So let's check whether we are right or wrong, or whether we have made mistake or not. Let's see whether we have made a mistake. 1.4. This is right. 2.4, this is also right. And then we have made a mistake. We have made a mistake. What? En square. Why did we miss it? Why did we miss it? This is not the subtraction.
Yes, sir.
This is not the
So we
subtraction.
didn't square it.
We didn't square it.
1.4.
Yes, we didn't square it. So this one will be square. So what was that? 2.54 minus 1.4 is square. And that will be 0.44. Okay, so we have made a mistake. And then that one actually is a square. So it's not a difference, it's a square. So if we know the square, then we can do it. And then the root over of variance, we have got this 0.663. Is it clear to everyone?
Yes, sir.
Okay, I think we have understood how to solve this kind of problems. Let's take this conditional probability. Already we know what is the conditional probability. So this conditional probability mass function is something like probability of x equal to x condition B, similar kind of thing. And this conditional probability, already we know that the conditional probability is Px divided by Pb. Can you remember?
Yes, sir.
We should be able to remember this equation, because that equation we know from our probability class. Because conditional, if there is a condition, then the last portion that will be in the lower side, and the first portion will be in the upper side. So Px divided by Pb, that is the conditional probability theorem. Okay. The thing is, conditional expected value, that also be found out, because expected value, we know that this is xpx summation. If it is conditional expected value, then similarly the probability will be replaced by conditional probability. So this is actually the similar kind of thing. And if we have the conditional probability or conditional expected value, so from the conditional expected value we can find out the total expected value. So there can be 2 or 3 conditions. That means there are 2 or 3, like like, say for example, like say we are having 1, 2, 3 conditions, B1, B2, B3. And say for example, this one is a probability of X condition B1. This is the probability of X condition B2. That has a probability X condition B3. Okay, so if we have expected value of X condition B, okay, like something like, say for example, X condition B1, we have a expected value of X condition B2, and also we have the probability of, or expected value of X condition B3. Then how to find the expected value of X? The rule is, it's a summation. Summation means Ex condition B1 multiplied by probability of B1 plus expected value of X condition B2 multiplied by probability of B2, then plus expected value of X condition B3 multiplied by the probability of B3. Do you understand?
Yes,
That's
sir.
what they are telling. That summation of all these probabilities. So we will multiply this probability with the expected value plus this probability with the expected value plus this probability with the expected value. All right. So
Yes,
we
sir.
can actually solve it like this. Okay. Now let's go to the next slide. Actually, this is the last problem of this chapter. So actually we have to complete our next chapter as well before the mid-semester exam, and hopefully today we will have at least one class on Tuesday, and we will be able to finish chapter 3 also, inshallah, no problem. Let's solve it. So the thing is, this is a quiz 2.9 on the internet. data is transmitted in packets. In a simple model for World Wide Web traffic, the number of packets n needed to transmit a web page depends on whether the page has graphic image or the text image or the text something. If the page has images, then n is uniformly distributed between 1 and 50 packets. If the page is just text, then n is uniform between 1 and 5 packets. Assuming a page has images with probability 1 by 4, find this. Okay. So actually, the idea is something like this one. The idea is something like we will have image or we will have text, isn't it? This is the idea. Image or we will have text. Now the thing is, if what is the probability of look at that, assuming a page has image with probability 1 by 4, that means this probability of image will be equals to 1 by
1 by
4.
4.
So definitely this probability of text will be equals to
3 by
3
4.
by 4, isn't it? Okay.
Yes, sir.
The thing is, they're telling if the page has image, then n is uniformly distributed between 1 and 50 packets. That means actually what? This is a kind of uniform distribution. So 1 to 50 packets means what? It's a uniform distribution like this. And what is the probability? 1 by 50.
So 1 by 50.
Can we say that?
Yes,
Yes.
sir.
Okay. Now this probability is known as probability of n condition I. Okay. So this is the probability of n, that is equal to 1 by 50. Okay. Now the thing is, actually, is it like that? Okay. Okay. Another probability is there, which is probability of n condition that text is in that. And that probability is what?
1 by 5.
That probability is 1 by 5, right? That probability is 1 by 5 because that is another uniform distribution from 1 to 5. And that probability should be 1 by 5. Okay. All right. Actually, that is not a, this actually would be something like this one, like this one. Not continuous, discrete. Okay. Now the thing is, okay. Now what actually they're telling? Look at this one. Number one, they're asking for conditional PMF, PN condition I. I think we have found it. Then conditional PMF N conditional T. I think also we have found it. Then they're trying to find out PMF of N. What is PN? PNN. Now the thing is, when I'm talking about PN, actually there are two possible cases. One is that actually this is a conditional probability. Remember one thing. This is a conditional probability. I told you already, if there are conditions, we need to find out the total probability. How to find the total probability? Total probability findings is something like this probability multiplied that conditional probability, and then this probability multiplied by that conditional probability. Isn't it?
Yes, sir.
Okay. So let's actually check. I'm not sure whether it is okay or not. Let's check whether we are writing, whether we are going in the right direction or not. Okay. So I think the first one is okay, isn't it? The first one
Yes,
I think is okay. This is the 1 by 50. And that conditional probability is 1 by 50 for n equal to 1 to 50, and then 0 otherwise. As it is a kind of, I mean, if it is PMF, then we should be writing like this. But if they are asking for probability, then 1 by 50 is enough. Okay, let's take the next one. The next one is 1 by 5, like this. Is it okay? So our first two, yes. Yeah, any question?
No, sir. No, sir. No question, actually.
Okay.
Sir.
So the thing is, now this first two answers are okay. Second one, the third one that we were talking about, the total probability. Our idea was right. Okay. The total probability findings, how the findings is done. I told you already. If there are things like this one, then we will multiply and then add. Okay. So what is that? We told you already that is 1 by 4 and that one is 1 by 50, isn't it?
Yes, sir.
And this one is 3 by 4 and that one is 1 by 5. So we are having a PMF kind of result. How to find out that one? Remember one thing. Why actually we are thinking like that? For different range, we are having different probability. When the value of n equals to 1 to 5, okay, like this one. When the value is 1 to 5, we will talk about this probability, also this probability, because they are valid for 1 to 5 and they are also valid for 1 to 5. Okay. And for this region, the value is something like 1 by 4 multiplied by 1 by 50. Look at that. This one multiplied by this one. Okay. Plus 3 by 4 multiplied by 1 by 5. 3 by 4 multiplied by 1 by 5. Is it clear?
Yes, sir.
So this first region where we have 1, 2, 3, 4, 5, then actually both the cases have probability. But the thing is, after 5, there is no probability here. The probability is 0, isn't it?
Yes, sir.
So when the value of n equals to 6 to 50, within this range, that this conditional probability will have a probability, but this will have a 0 probability. So what is the value? Like the previous one, 1 by 4 into 1 by 50 plus 3 by 4 into 0. And that will be equal to, not this one, not this one. That will be equals to this 0. So after calculation, that becomes 0.05. And the previous one, that one, and the previous one becomes this one, that is 0.155. So this is for the first 5 value range, and this one is for the second 5 value range. And there is a mandatory value of 0, otherwise will be placed here, because this is a PMF. So PMF of n will be calculated like this. Is there any question from your side? Is there any question?
No, sir.
Just a minute. Sorry for the interruption. Actually, I call. I had to attend the call. All right. So, are you here?
Yes, sir.
Okay. Okay. So the thing is, we can understand now the question number 3. No problem. Okay. Now, what was the question number? Um, um, what question number 4? What was the question number 4? Let's see the question number 4. The question number 4 was, look at this conditional PMF. Okay, conditional PMF. There was another question, which was a conditional PMF of this probability of n, condition n less than 10. Okay, remember one thing, we know the conditional probability. If it is probability of something like n condition n less than or equal to 10, okay, if it is something like this one, that should be equal to probability of n divided by probability of n less than equal to 10, like this, isn't it?
Yes, sir.
Yes, sir.
We know this formula. So this Pn we have already found out. This is the Pnn. Now if somehow we can find out this one, then we can easily solve it, isn't it? Okay.
Yes, sir.
Now how to find probability of n less than or equal to 10? Okay, probability of n less than equal to 10. Now the thing is, we have actually from packet 1 to 50 for first case and 1 to 5 for second case. So similarly, actually, we can find out probability of n less than or equal to 10. That means what? That means we will have this first category with 1 by 4 and then some 1 by 50 up to 1 to 50, and then we are having 3 by 4, then 1 by 5 from 1 to 5, isn't it? So if it is 1 to 10, look at that. This is actually 1 to 10. So if it is 1 to 10, similar kind of thing will happen, isn't it? Because from n, if I say that from n equal to 1 to 10, then what will happen? I think it is something like 1 to 5 and then 6 to 10. We have found out this probability of n. Okay, now the thing is, we should be able to find out, because if the n value is from 1 to 5, then we can write it something like 1 by 4 into 1 by 50 plus 3 by 4 into 1 by 5, and then when n will be equals to 6 to 10, then it will be 1 by 4 into 1 by 50 plus this is 0, isn't it? That is 0.
Yes, sir.
So similar kind of probability will come like we have found in the probability of n. There will be 3 different item will be there. It is 1 to 5, 6 to 10, and 0 otherwise, isn't it? Let's see.
Yes, sir.
Let's see their result, what they are telling. Okay, I haven't checked it actually. Let's see. No, they are not doing it like this. They're just taking something like that. Okay, okay, okay. I understand. I understand. How do they do that? Did you understand? How have they done it? Remember one thing. Remember one thing. The thing is, the probability of n we have calculated already, isn't it?
Yes, sir.
This is the probability of n. This is the PMF. We are not actually finding the PMF. We are finding probability of n less than equal to 10. This is an specific probability, because I am not talking about all the values of n, I'm talking about up to 10. It's a kind of CDF, if you can remember. 1, 2, 3, 4. If I'm talking about 10, then when I'm talking about probability of n less than equal to 10, it means I have to add all these probabilities, isn't it? Do you agree with me?
Yes, sir.
Actually, n is from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, many things. But this up to 1 to 5, look at that probability of n. Up to 1 to 5, we have a probability of 0.155. So these are with 0.155 probability. Okay. And then these values are still smaller even. These are even smaller. If we can see this one. If you can see this one. These values are smaller, and that value is actually how much? 0.005. 0.005. Do you understand?
Yes, sir.
Pn is a probability by which we can find out any value of n probability, and that is given. By given means that is already we have calculated. Now we want to find out probability of n less than or equal to 10. That means the probability summation of the probability for n equal to 10, n equal to 1 to n equal to 10. Now what we have to do? We have to add this one, this one, this one, this one, this one, and then we have to add the later one, 5 to 10, isn't it? So if I want to do that, this much probability is there how many times?
Up to 5.
5 times. So 5 into 0.155, and this probability is how many times?
Up to 50.
50 times.
Actually they are talking about n less than equal to
Yes.
10,
Then
So
sir,
10
five.
times.
not 10 times.
Five.
This is starting from
times.
6.
So 5 times.
This is starting from 6.
5 times.
5 times. 6, 7, 8, 9, 10. Do you agree? I'm
Yes,
telling
sir.
it again. I'm telling it again. This 0.155, these were for 5 times because for 1, 2, 3, 4, 5. And this 0.005 again 5 times because this is for 6, 7, 8, 9, 10. We will not go for 11 because it is told less than or equal to 10. So that will be added with 5 into 0.005, and that will be the probability of n less than or equal to 10. Is it clear?
Yes, sir.
Okay. If it is not clear, please go through the solution. It will be clear, inshallah. Otherwise, we will let you understand later on. Okay. So this is how they are doing it like this. Look at this. They are doing it like this. They are taking 5 into 155, 5 into that is 0.80. So up to 10, if I add all the probabilities, that will be equals to 0.8. Now we know that this probability is equal to what? Probability of n divided by probability of n less than 10. Okay, so this probability of n has 3 different range, 1, 2, and 3. And every range is divided by this 0.8 because this is the value 0.8 coming from here. So that by 0.8 for this region, that by 0.8 for this region, and 0 by 0.8, that is 0 or otherwise. So the new value of this probability of n condition n less than or equal to 10, that will be equals to this one. This one. Is there any question regarding this one?
Sir, if we were asked to find probability of n conditional n when n is less than equal 50, sir, would it be 1?
Definitely.
Okay, sir.
Less than or equal to 50.
Yes, sir.
That would be equal to definitely 1. You can check. Look at that. If it is less than equals to 50, then what happens? This 0.155 will be multiplied by 5 and then plus 45 multiplied by this 0.05. If you add, that will be equals to 1.
Yes, sir, it's 1.
Okay, so if you do that, actually this will become 1. Because actually probability of n condition n will be equals to 1. Because if we know already n, what is the probability of n?
1.
From the theory, we know that if we already know the n value, then what is the probability of n? It will be 1. So our theory actually is satisfied in this example. Okay, is there any other question?
No, sir.
Okay. Okay, the next question was actually this one: expected value of n condition n less than 10. Okay, and definitely that would be n pn summation. This pn already we have understood, and this is from look at that. This is from n equals to, I mean, expected value of n less than 10 means actually this is from 1 to 10, isn't it? So there
Yes,
are
sir.
two range. One is 1 to 5, another one is 6 to 10. So you use the n into pn plus n into pn and you will find the value. Very easy. It's very easy. Okay, because this probability we are finding the expected value. So n into pn summation, and this particular pn or particular probability has 3 range. One is this range, another one is this range, another one is 0 otherwise. That can be ignored. So we will do it like that, and then we will find out the result, the expected value. Okay, is it okay?
Yes, sir.
All right, then we will talk about this the last one, that is variance of this. Look at that. Actually they are telling to find out the variance of this one. Very easy. We have found out the expected value of this value. Now we need to find out expected value of any square, because we know variance equal to what? Expected value of any square minus expected value of n
Whole
whole
square.
square. So that one we already know, and that one we need to find out. That's why they have found out expected value of any square condition n less than 10, and this is any square into pn summation. The same thing, just any square will be there. Any square will be there. So it will be 1 square, 2 square, 3 square, 4 square, 5 square, like this. And then you will add and you will find out this one. And now this 12.71 minus this 3.1 square, and that will be 2.75684. Just the calculation. Okay, I think you'll be able to understand how they have solved. Is it clear? Is there any question regarding this solution? No question. So let's complete, or let's finish it. So this is the end, I think. Yes, this is the end of chapter 2, and we will just straight away start chapter 3. Okay, let's start chapter 3. Okay. So this one is chapter 2. Okay. Chapter 3 actually will be easy to go on, because similar kind of things will be there, but we have to be very quick to finish it. Okay. So let's Let's share chapter 3. Can you see it?
Yes, sir.
Okay. Look at this. This is the chapter 3. That is the continuous random variable. Okay. This is the continuous random variable. And in this continuous random variable, we'll skip this one. Okay. What is the continuous number of continuous random variable? Just a very short, I will say, short come up with. Say, for example, in the discrete case, discrete uniform was like this, isn't it? Say for
Yes,
a
sir.
for a roll of a die or dice case, it was something like every outcome was with 1/6 probability. And remember one thing: there is nothing between 1 and 2. Is there anything between like 1.5? No.
No, sir.
There is only 1, 2, 3, 4, 5, 6 outcome possible. But in the case of continuous random variable, any value is possible. And in the particular case, this particular discrete random variable becomes a discrete uniform random variable becomes a continuous uniform random variable like this 1 to 6. And there can be any value possible like 2.1, like 4.6. Okay, so any value possible. This is the continuous random variable. I think you have understood what is the continuous random variable. So there are lots of language here. I think that will not be much important. But can you say what kind of random variable it is?
Continuous.
Continuous, because there is no gap. But if it is something like this one, then it will be a
Discrete.
discrete random variable. Okay, so I think we have understood what is a continuous random variable. So we will skip this example and straight away we'll start with this cumulative distribution function, that is CDF. We already know what is CDF, isn't it? Remember one thing: in
Yes, sir.
the previous case, we have started with PMF and then we have gone to CDF. But in the case of continuous random variable, we will start with CDF and we will derive the PDF. Because actually this CDF is a value from which we need to find out PDF, because we cannot directly say what is PDF. Because this PDF, if you want to find out, it will become undefined, something like that. So let's do the CDF first. We know already that the CDF is what? Probability of x less than or equal to x. We have many probabilities and there is a value of x. So before the value of x, whatever are the number of probabilities, we will sum. We will add. That will be the fx. And we know the criteria of fx. Function of x or fx equal to minus, or fx at minus infinity will be equal to 0. We already know that. Fx at plus infinity is equal to 1. We already know that. And remember one thing, this is very important. Probability from x1 to x2 is the CDF at x2 minus CDF at x1. What does it mean by that? Let's solve it. Let's explain this one. The thing is, when I'm talking about CDF, say for example, that one is a some, say for example, this one is a probability PDF. This is a PDF and that is the X. So X versus PDF curve. So it is something like it is increasing like this one. We know that this is a continuous random variable. That's why the PDF is a continuous random variable. Now they are telling PDF from X1 to X2. This PDF is what? It is telling that at X2, whatever is the CDF and act X1, whatever is the CDF, if I subtract those two CDF, then we will get it back like this one. Say for example, what is F2? F2 is a probability summation. So actually summation means adding all these, isn't it? All these. This is the F1. I mean F2, if it is something like that. F2. What is F1? F1 is summation of all these, isn't it? Or we can say
Yes, sir.
that this is the F2. Now if I subtract F2 minus F1, what is the result? The result definitely is this portion, this red dash portion, isn't it? Because
Yes, sir.
F2 is the whole area, F1 is the left area of X1. So if I subtract F2 minus F1, definitely that will be between X1 and X2, that area. And that area is what? Probability of this random variable from X1 to X2. So that actually is the probability from X1 to X2. Okay, so the CDF criteria number 3 is something like, if we subtract 2 point CDF, we will find the probability from that point to the other point, and these two are the same. Okay, is it clear?
Yes, sir.
Okay, almost. So,
Sir?
yes,
Sir, x1 is less than x. Sir, is this x a certain point or a certain range?
X1,
Sir, the x that you have marked with green color.
this one.
Yes, sir.
This X is a random variable. This X are those values of X which are between X1 and X2. They are telling the X is a random variable which is between X1 and X2 and their probability summation. So it is X1 plus this plus this plus this plus this plus this plus this, all the points probability. So these are all X. Do you understand?
Yes, sir. Sir, shouldn't the position of x alter the subtraction value fx of x x2 and fx of x minus x1? Sir,
Alter means
sir, shouldn't it change it? Like the position is changing, it's not discrete. So the summation shouldn't change along with the position of x.
actually I'm not clear what actually is your question.
স্যার এক্স এর ভ্যালু যদি বাড়াই বা অথবা কমাই তখন হচ্ছে আমাদের মানে কি বলে সিডিএফটাও তো বাড়ছে আর কমছে না।
অবশ্যই অবশ্যই।
আচ্ছা স্যার এটাই
এখানে let me answer the question like this. Okay, say for example, these two are two different side. Let's solve the first right hand side. What do you mean by this fx2 minus fx1? Isn't it this green area?
Yes, sir.
Look at that area. I'm talking about area. This green area is the right hand side. Is it clear?
Yes, sir.
Okay, fine. Now the left side is probability of x from x1 to x2. Actually, when I'm talking about the PDF, actually we haven't solved the PDF first, but let's think about this one. Say for example, like this. Say this is the thing, and this one is x1, this one is x2. Okay. Now this probability, look at this CDF definition. CDF definition, when I'm talking about that, this CDF is an area of probability which is between I mean, which is less than equals to x. What does it mean? It means from minus infinity to x,
Yes, sir.
isn't it? So
Yes, sir.
actually this is the area from minus infinity to x. So if it is something like this, minus infinity 2x less than x or equal to x, something like that. So if I can say that this is this definition, and I'm telling that this is the area from minus infinity to x, this is the similar kind of definition.
Okay, sir. I understood.
Can't I say that it is the area from x1 to x2?
Yes, sir.
That actually is the definition, or you can say the things like that. Okay,
Thank you, sir.
okay. So this is the CDF. I think CDF is clear to you all. The CDF is similar. Yes. Yes, please. You have a question?
No, sir, I don't have a question. I just think yes, sir. That
Okay,
CDF
okay.
was clear.
Okay. So let's go talk about this quiz 3.1. Quiz 3.1. Actually, why did we miss the PDF? Where is the PDF? Oh, PDF is coming later on. Okay. So let's solve the quiz number 3.1. Let's see how this quiz 3.1 works. Okay, so the thing is, the cumulative distribution function of the random variable y is given. Okay, the cumulative distribution function of y is given, and then you sketch the CDF of y. Sketch the CDF of y and calculate the following probabilities. What is the probabilities? Probability of y less than equal to -1, probability of y less than equal to 1, then this one, then this one. Okay, so let's draw the CDF if possible. Okay, so the CDF is something like y is less than 0, there is no CDF, and y is more than 4, it is 1. So actually it is some kind of starting from 0 and going to 4, isn't it?
Yes,
This
sir.
is 0, this is 1, 2, 3, and then 4. Okay, the thing is, if it is y is more than 4, then it is actually 1, and this is something like y 0 to 4. So actually the CDF equation is given, it is equal to 1 by 4. So if y equals to, and this is the CDF of y versus y, and if y equals to 1, it is 1 by 4. If y equals to 2, then it is 2 by 4, that is half. Can you understand how I'm drawing?
Yes, sir. Yes, sir.
Then it is 3 by 5. So it is something like
The
1 by
hyperbola.
4 hyperbola kind of thing. 1 by 4, then I think it is kind of something like this, or maybe different. Let's draw it again. Let's draw it again. Okay, say for example, if this is the 1, 2, 3, and let's see, that is the probability 1, this is probability half, this is probability 1 by 4. Okay, so 1 means 1 by 4, 2 means like this, 3 means like this, 4 means like this. So it's a kind of things like that. Okay, kind of things like that. So this is the CDF of y. So the first one is a sketch. The CDF of y we have already sketched. Calculate the probabilities y is less than -1. What will be that one?
0.
0. Very good. Because there is nothing before 0. If I talk about -1 and we are talking about before -1, there is no probability. So that is 0. What about number 2?
Sir,
Probability of y is less than 1.
Less
sir,
than or equals
from
to
the
1 by 4.
yes.
Actually, when I'm talking about probability of less than 1 by 1, like I think it is 1 by 4, isn't it? Because CDF means the probability before that particular point. So when I'm talking about y equals to 1, and if I find out the probability of y, I mean CDF of y, that will be equals to 1 by 4, and that is meaning that the probability before point 1 is the CDF, that is 1 by 4. So that will be equals to 1 by 4. What about number 3? Probability between 2 and 3. Between 2 and 3. What is the probability? That should be something like probability of y at 3 minus CDF at 2. Isn't it like that?
Yes, sir.
That probability, if I am talking about this area, that area should be something like this one. Because if in F3, if I'm talking about this one, if I'm talking about this particular thing, that is the F3, and that one is F2. So if I'm talking about F3, it means the whole area. F2 is this particular area. Then if I subtract, I will find this particular area. Isn't it? So F3 means 3 by 4 minus 2 by 4. That will be equals to again 1 by 4. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now the thing is this one. Probability of y more than 1.5. What does it mean?
Sir,
1.5 is something like there. How will you do that?
sir,
Tell
from
me.
1 we subtract the probability of 1.5.
Very good. Very good. Actually, from the concept of CDF, our job is to find before a particular point, not after a particular point. But if we want to find out the after a particular point, then we have to use a trick. And the trick is this whole area is definitely equals to
1.
1, isn't it? So if the whole area is equal to 1, then actually if I find the probability at uh, 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 1.5 or CDF at 1.5, that is this particular area. I mean, this is this particular area, isn't it? So our job is to find out that area, this area. I mean, our job is to find out this area or something like this one, this area. And that area can be found out from the whole area minus this particular area, isn't it?
Yes, sir.
So we can easily find out that also by finding 1 minus CDF at 1.5. Let's see whether our idea is similar with the author's idea. Let's see. First one is 0. Second one is also 0. I mean also the 1 by 4, and we have seen already. That one is 3 minus 2. Okay, fine. And that one is, look at that. Our idea is similar than with the author's idea. 1 minus this one actually is the same as CDF at 1.5. Okay, this is already given 1.5, and that is actually 1.5 divided by 4, and that is 5 by 8. Is it clear?
Sir, how did we get the value of probability of y less than or equals to 1.5?
Look at that. What is CDF? The CDF is something, any point when I'm talking about CDF, that means value less than that particular point.
Yes.
The CDF equation is given. The CDF equation is equal to y by 4. If any value from 0 to 4, then we will use this formula. And
Yes.
then 1.5 is a value between 0 to 4. So the CDF at 1.5, we can easily find out by using 1.5 divided by 4.
Yes, sir. Of course.
That is the CDF at 1.4. That is actually the area of this one. Is it clear?
Yes, sir. It's clear.
And then we have found out like this, and then we have put it, and we have found out 5 by 8. Okay?
Yes, sir. Thank you.
How much time we have? We don't have time. So let's stop it here, and we will try to finish the chapter in the next class, inshallah. So thank you very much. I'm giving you the attendance.
Sir, may I ask something?
Number 59, 17 batch.
Yes, sir.
Then
Present, sir.
117.
Present, sir.
Roll number 1, 18 batch.
Yes, sir.
2. Roll number 2. 3.
Yes, sir.